All right, so that's the intro to the fundamental theorem. And now what I need to do is extend it just a bit. And the way I'm going to extend it is the following. I'm going to do it on this example first, and then we'll do it more formally. So here's this example where we went someplace. But now I just want to draw you an additional picture here. Imagine I start here, and I go over to there, and then I come back. Okay? And maybe even I do a round trip. I come back to the same place. Well, if I come back to the same place, then the position is unchanged from the beginning to the end. In other words, the difference is 0. And the velocity, technically, rather than the speed, it's the speed to the right and the speed to the left maybe are the same, but one of them is going in the positive direction, one of them is going in the negative direction, and they cancel each other. So if you have this kind of situation, we want that to be reflected. We like that interpretation, and we want to preserve it even when in the case when the function v is negative. And so I'm going to now extend our notion of integration. So we'll extend integration to the case f negative or positive. In other words, it can be any sign. Actually, there's no change. The formulas are all the same. We just, if this v is going to be positive, we write in a positive number. If it's going to be negative, we write in a negative number. And we just leave it alone. And so here's, let me carry out an example and show you how it works. I'll carry out the example on this blackboard up here of the sine function, but we're going to try two humps. We're going to try the first hump and the one that goes underneath there. So our example here is going to be the integral from 0 to 2 pi of sine x dx. And now, because the fundamental theorem is so important and so useful and so convenient, we just assume that it be true in this case as well. So we insist that this is going to be minus cosine x evaluated at 0 and 2 pi with the difference. Now when we carry out that difference, what we get here is minus cosine 2 pi minus cosine 0, which is negative 1 minus negative 1, which is 0. And the interpretation of this is the following. Here's our double hump. Here's pi, and here's 2 pi. And all that's happening is that the geometric interpretation that we had before of the area under the curve has to be taken with a grain of salt. In other words, I lied to you before when I said that the definite integral was the area under the curve. It's not. The definite integral is the area under the curve when it's above the curve, and it counts negatively when it's below the curve. So yesterday, my geometric interpretation was incomplete and really just a plain lie. So the true geometric interpretation of the definite integral is the plus the area above the axis, above the x-axis, minus the area below the x-axis. All right, as in the picture. I'm just writing it down in words, but you should think of it visually also.